Hello friends. In this session, let us go through the 8051 program for this particular question. Write an ALP for decimal up counter. Now we have a note with respect to this one. So in the question it is clearly said it's a decimal up counter. So counting has to happen from 00 up to 99. So since all the values being taken inside 8051 as a hexadecimal, actual range will be always from 00H to the FFH. But it is clearly asked in the question here, we are not with the hexadecimal, we must have only the decimal counter, that is from 00 to 99 only. Beyond this months, it must come back to 00 only. So in 8051 we are having an instruction called DAA, so which is going to convert the resultant to the decimal. So that's why decimal adjust accumulator is what the instruction. So we must make use of this instruction in order to have the decimal value. That DAA instruction is going to work only after either add instruction or add with the carry instruction, and in this particular case we are just making use of the add instruction. After using the add instruction we must make use of the DAA instruction so that the outcome of the addition can be converted to the decimal value. Now let us go through the program for this one. So here I'll be showing you two programs. So one is this program which is as simple as possible, very best understanding of the concept. So another one is very best for observing the output. So both of them I'll be showing you over here. Right. So now we'll be starting with the execution. Move a comma hash 00. So that means the starting point is always the 00. Therefore accumulator is loaded with the initial value. So after execution, so accumulator we are going to have the value 00. Then add a comma hash 01h. See again reminder. So we can make use of the instruction increment a also, but we want the result in decimal. So for that we need to make use of the DAA instruction, and this DAA is going to work only for the add or add with carry instruction. Therefore we cannot make use of the increment instruction here. We must make use of the add instruction, that to be incremented by 1 only. So add a comma 01. So you can observe the result in the accumulator over here. So after that we are having the value 1 over here, right? So 1 itself is a decimal value. So DAA instruction is not going to have any effect on this one. Therefore after the execution of DAA also, the contents of accumulator remains as it is, no changes, right? So now when it is going to change, or what is the point to be observed, after accumulator become equal to 9, what is the next value? Our expectation is 10 and we have to get it as 10, not as a. That is one observation. Second observation is after 99 the value must come back to 0. That's the second observation. These are the two major points to be observed. Now let us move on to the second value. So in the second value again it is 2. Then I will take it a little bit faster. 5, 6, 7, 8, 9 has happened. Now the value first it goes to A. First it goes to A after addition, and after DAA it has shifted to 10. So we are in the decimal only. So now this is what we are going to have. So now what is the problem with this one? So where the result to be stored, nothing has been mentioned. So let the result be in the accumulator itself, and we can have a clear observation of the result in the accumulator here itself. But the problem is, if we keep directly run the program, that means step by step it will take a long time to reach 99 and then to switch over back to the 0. That is going to take a long duration, that is 99 times we have to run this loop. Otherwise if we use this run option, then we cannot observe any changes over here. You just make an observation of that. I'll be directly saying run option. So it is program is running, but we cannot observe any changes in the accumulator content, right? So that means if we stop, then whatever the contents of the accumulator when it stopped, so that is observable. change in the value 1, 2, 3, 4, 5, 6, something like that is not observable. So that's why that to make it observable, we are just moving to the another program, and let us have a view of that program also, right? Now this is the another program what we are having. Conceptually, there is no change. We cannot change the basic concept of it. But to make the output visibility much clearer, we are copying the contents of accumulator to the port 0 so that we can view the answer over here. And to have a clear visibility of change in the number from one value to the another value, we are introducing a delay over here. And this is what the delay subroutine. See, there is no specific time that has been taken over here for calculation and all those things. Nothing is there. You can make use of any random delay program over here. So in the upcoming programs also, we do have a same procedure and we do require the delay, and I am using the same program further also to create a delay value. Right. So now let us have a execution. So one or two loops I will be taking that in a step-by-step manner, and further I will be directly running this program. Now sequentially, first step, so move a comma 00h, so a is initialized. Take that accumulator value to the port 0. Currently all high values are available. Make them equal to 0. It is done. Then make a call for the delay, so that from 0 to 1 there must be a display delay we must have. So delay has been done, and then add a comma 01h. So incremented, convert that to the decimal DAA instruction. So then short jump to the back. So now what are the contents in the accumulator? Again move it to the port P0. So currently it is equal to 0. It will be updated to the value 1. Right? So then after a small delay, then use the add instruction. Now this is what the procedurally there is no variation. What we observed previously, the contents only in the accumulator, same contents of accumulator is being transferred to the port 0. And you can observe the values over here as well as in the binary pattern over here, the bit patterns, right? Now I will use the direct run option, and now we can also observe the change in the values 0, 1, 2, 3, 4 like that in this particular location. Just make an observation of that. Now I am running this one. So now here you can observe the change in the values after 9, it is 10, 11, 12, 13. So after 19, 20, so that you can observe the bit patterns changing, that also you can observe. In the previous program, in spite of having the correct result, we are not able to observe such a change when we use the run option. Instead, we used to do that in a single step manner. Now also in the accumulator we cannot observe any changes, but the same we can observe the changes over here. See, after 99 it is again 0. Okay, this was the observation needed. So for that purpose the program length has been increased, but basic concept has not been changed. Thanks for watching.